Hi, Algebra 1. So this is going to be for notes for 3.5 and other ones. So listen for the breaks in the lesson because you might need to either go forward in the video or back. So just make sure your top right of your paper is matching up to the pages that I'm on. Okay, so this is something called clearing fractions. And this means that we would be able to work the problems out by eliminating the fraction, and it makes it easier to work with. Okay, so number one here says fractions slow people down. Okay, and we know that. Actually, I'm going to switch over to this one. So let's scroll on up for here. 3.5, we need to be at. All right, so fractions slow people down, working with fractions. This video might have been, if you watched the last video, would have been on there as well. So some of the practice problems will be worked out already. Okay, it's easier to see the structure when you're not dealing with fractions. You avoid multiple operation errors if you get rid of the fractions first, which is great, and it makes it a little nicer problem to do. Okay, so we're just going to head down to the problems. Take a look at problem number one. If I can get my All right, so this very first problem, it's very simple as it's set up because you have the same bottom number. The denominator is the same. So what I'm going to do is watch this. If I multiply everything by 15, that goes ahead and the 15 here cancels out, and that leaves me a. This 15 cancels out, leaves me plus 4. This 15 cancels this out, makes it 9. So subtract 4 from both sides. You have a very simple problem, just getting a equals 5, which is pretty cool. When we move down, we start taking a look at it and notice this one on number 2. We have a denominator of a 3, we have another one of a 2, and we have a third one of a 3. So a lot of times you can just kind of multiply them together to get the term to multiply everything by. So I'm going to multiply 3 times 2, which is 6. I could multiply times the other 3 to get 18, but I think 6 is going to start canceling things out. So if I multiply everything by 6, this 3 would cancel this 6 out, make that a 2. So 2 times 1x is 2x. And then I'm going to cancel this out. 3 times 1x is 3x. And this 3 cancels into the 6, makes that twice. And that's going to make it a 20. So if we add these together, those are like terms on the same side. That gives me 5x equals 20. Divide each side by 5. These cancel out, so x is equal to 4. Next problem, we only have 2 of the parts of the problem that have a fraction, and it happens to be 2. So if I multiply everything, all 3 terms by 2, then we can go ahead and start reducing. Those 2's cancel out. I'm giving you a 1. 1 times 3x is 3x plus 6. This 2 cancels that one out. 1 times 9 is 9. Go ahead and subtract 6 from both sides of the equal sign. Those cancel. That's going to give me 3x is equal to 3. Divide each side by 3. 3 over 3 is just 1. Problem number 4. We have 2 of the terms that have a denominator, a bottom number. In this case, there is a 2 and a 3. So if I multiply each of my 3 terms by 6, 2 goes into 6 3 times. So 3 times m is 3m plus 3 goes into 6 twice, and that's 2m. Excuse me. And then 5 times 6 is 30. Those are like terms because they're the same. They have the m on both of them. 3m plus 2m is 5m. It's equal to 30. Divide each side by 5. These cancel out, so m is equal to 6. Problem number 5. Again, 2 of our terms have a denominator, a bottom number. In this case, they happen to be a 3 and a 4, so 3 times 4 is 12. So if I multiply everything by 12, 3 goes into 12 4 times. 4 times 2g is 8g. And then 4 goes into 12 3 times. 3 times 1 is 3 and had a g attached to it. And then if I multiply 11 times 12, I get 132. These are like terms, 8g and 3g, that's 11g, that equals 132. Divide each side by 11. So using a calculator, 132 divided by 11 is just 12. So it makes the problems much simpler if you get rid of the denominator. Okay, so our worksheet 3.5 is what we're going to do. I will work out these problems, but just know that if you just copy these down, that means you didn't learn it. You're just copying down. So you maybe use this as a tool to guide you along to do these problems. The first few problems are already worked out. So it looks like the first one, we multiplied everything by 7. The second one, I multiplied everything by 15. And this one didn't get quite done. So 9 divided by 3 is 3. Now we're going to get down to these that haven't been worked out yet. Okay, so on number 3, the bottom numbers are 4, 2, and 8. So think about a number that could be one of those numbers that 4 and 2 and 8 all go into. And the answer is 8, because 4 goes into 8, 2 goes into 8, and 8 goes into 8. So 4 goes into 8 twice, so I get 2m, plus 2 goes into 8 4 times, that gives me 4m. And then those 8s cancel out, so 1 times 30 is 30. So I wind up with 6m equals 30. Divide each side by 6. So m is equal to 5. Problem number 4, all 3 terms have a denominator. They have 4 and 3 and 4. So think about a number that 4 goes into and 3 also goes into, and that would be 12. So we're going to multiply everything by 12. This is going to get rid of some fractions. 4 goes into itself once, goes into 12 3 times. 3 times that, 3 is 9. Okay, that's a 9. Let me erase that and make it a little nicer. 3 times 3 is 9. Minus 3 goes into 12 4 times. 4 times 1x is minus 4x because there's a minus sign. And then 4 goes into 12 3 times. 3 times 1 is 3. Let's go ahead and start solving this. I'm going to subtract 9 from both sides first. So I'm going to get negative 4x is equal to negative 6. Let's divide by both sides by negative 4. Negative over negative is positive. 6 over 4 reduces to 3 over 2. So a reduced fraction you don't really want to make it a decimal. Just start getting into the practice. If it's a fraction, deal with a reduced fraction. Number 5, we have 3 denominators. We have 3, 8, and 2. So we have to think about a number that 3 goes into, 8 goes into, and 2 also goes into. So I think it's going to be 24. What do you think? So then 3 goes into 24 8 times. 8 times that 2 is going to give me 16x. 8 goes into 24 3 times. 3 times negative 5x is negative 15x. And then 2 goes into 12 or 24 12 times. And 1 times 12 is 12. Go ahead and combine these like terms. That's going to give me 1x, which is the same thing as x, so x equals 12. So that worked out very nicely. Number 6, we could add 3 to both sides first, but let's just stay constant. Let's multiply everything by 2, and that's going to get rid of that fraction. That gives me a 1. 1 times 1x is just x. Minus 6 equals negative 14. Add 6 to both sides. Those cancel, so x is equal to negative 8. Number 7, 2 of the portions of this problem have a denominator of 2. So if I multiply everything by 2, all 3 of the terms by 2, this 2 cancels that out. 1 times negative 1x is negative 1x. 2 goes into 2 once. 1 times 3x is 3x. 2 times 20 is 40. And so we can subtract 3 from both sides. So we're going to get negative x is equal to 37. Basically, the math that's taking place is you're multiplying both sides by negative 1, or you just flip-flop the signs and get the correct answer. Problem number 8, we have 3 denominators. We have a 5, a 10, and a 2. So think about what number goes into 5. What number would 5 and 10 and 2 go into? And sometimes it could be one of those numbers, and I think it's going to be 10. So we're going to multiply everything by 10 first. 10 goes into there, or 5 goes into 10 twice. 2 times 2a is 4a. Plus 10 goes into 10 once. 1 times 3 is 3. 2 goes into 10 5 times. 5 times 3 is 15. Go ahead and subtract 3 from both sides of the equal sign. So I'm going to get 4a is equal to 12. Let's divide both sides by 4. So a equals 3. And then these last two, perhaps your teacher could work out if you wanted to see those. This will be our next day of notes. So if you're looking at yesterday's notes, don't look at this portion of the lesson to take care of. So, but this is for 3.6. Make sure the top right of your paper says notes for 3.6. And we're going to start solving literal equations. And you've seen literal equations like area equals length times width. That's for area of a rectangle. Or distance equals rate times time. That's how you would find the distance of something. And then there's one that's y minus y sub 1 equals m times x minus x sub 1. That's called the point slope form of a line. And then we have p equals 2l plus 2w. That's how you would find the perimeter of a rectangle. So you want to make sure you identify what letter they want us to solve for. Treat all the other variables like numbers. Those are constants. Use inverse operations such as add or subtract, multiply or divide to isolate the desired variable and simplify if needed. Okay. Why they're useful? Literal equations let you rearrange formulas so you can plug in known values to calculate what you need. It's common in science and geometry and algebra. All right, so the first one is number 1. Area, or A, equals length times width, or L times W. They want to get L by itself. So these were being multiplied. Now they're going to be divided. So L equals A divided by W. Done. Number 2, solve for R. So we want to get R all by itself. R and T are being multiplied together. So if I divide both sides by T, I'm going to get R equals distance divided by time. And these are simple ones, but I can assure you future literal equations in other math classes and other science classes, it really will help you out. For problem number 3, we want to get y by itself. So I have a positive 2x. So if I subtract 2x from both sides, those cancel out. So I get y equals 24 minus 2x. Some teachers might want you to have the x value first. So I think both these answers are fine. Number 4, we want to solve for y again. So I'm going to subtract 3x from both sides. Those cancel, so I get negative 2y is equal to 6 minus 3x. Divide both sides by negative 2. Notice you made a big fraction on the one side. So y equals 6 over 3x divided by negative 2. All right, we want to solve for w. So I'm going to subtract 2l from both sides first. So I'm going to get p minus 2l is equal to 2w. Divide both sides by 2. So w is equal to p minus 2l divided by 2. Number 6, we want to solve for a. So I'm going to subtract 6b from both sides first. Those cancel out, so I get 5a is equal to 10 minus 6b. Divide both sides by 5. A is equal to 10 over 6b all over 5. There's your answer. All right, this is the worksheet. If you just copy these down, that means that you don't know it. You're just copying. So use this as a guide. So we want to get y by itself, so I'm going to subtract 3x from both sides first. So y equals 6 minus 3x, and we're all done. For problem number 2, we want to get y by itself again, so we're going to subtract 2x from both sides. Those cancel, so negative 3y is equal to 6 minus 2x. Divide both sides by negative 3. Those cancel, so y equals 6 minus 2x divided by negative 3. For problem number 3, it says solve for x, so we want x by itself on this one. I'm going to subtract y from both sides. Divide both sides by 3. It's done. Number 4, we want to get p all by itself, so I'm going to subtract 2l from both sides. So a minus 2l is equal to p. Number 5, m and g are being multiplied together, so I'm going to divide both sides by g to get m all by itself. So I find that m equals w divided by g. F equals m times a. I want a by itself, so m and a are multiplied, so I'm going to divide both sides by m. We're going to solve for w on this. So there's a couple ways we could do this. Let's go ahead and distribute first. So a equals 2l plus 2w. And again, I want to get w by itself, so I'm going to subtract 2l from both sides. So a minus 2l is equal to 2w. And then what we're going to do is we're going to divide both sides by 2. So W is equal to A minus 2L divided by 2. On this one, we want to go ahead and solve for y, and it says we also want to remove the parentheses. So I'm going to distribute over. So I'm going to get 1 minus 2. 1/2 times x is half x. Half of 4 is 2. We don't need to clear the denominator on this, so let's just leave that there. We're going to add 2 to both sides. Those cancel out, so y equals 1/2 x plus 4. For problem number 9, we want to get h by itself. Well, pi and r and h are all being multiplied together. So I'm going to divide both sides by pi r squared. And that's going to leave me h equals v over pi r squared. For problem number 10, we want to get a by itself. So I'm going to multiply both sides, or we want to get y by itself. So I'm going to multiply both sides by 2. So I get 2a is equal to, those 2's cancel out, x plus y. Then we're going to subtract x from both sides. So I'm going to get y equals 2a minus x. All right, now we're going back to just solving. Okay, how many times does 4 go into 8? Twice, so I get 2y. How many times does 4 go into 12? 3 times, and don't forget it's a negative. Now we got rid of those signs. Let's add 2y and 3y together. That's 5y minus 3 equals 22. Let's add 3 to both sides to get to 25. Divide both sides by 5. So 25 divided by 5 is 5. For number 12, that negative needs to come over the parentheses. So I'm going to get 18x minus 12x plus 4. And then I'm going to multiply over here. That's going to give me 6x plus 18 minus 14. I do have like terms on each side, so 18x minus 12x is 6x. And then 18 minus 14 is 4. We get positive 4. Subtract 6x from both sides. What do we get? We get 4 equals 4. That's true, right? 4 is equal to 4. So we have infinite solutions or all real numbers or something like that. Might want to ask your teacher to check on number 13. We're finding the mistakes, so double check that, see what they might have done wrong. This is our next lesson, so if you're continuing to watch the video, realize you might be into the following day's lesson. So take a look at your upper right-hand corner of your paper. Make sure you're at worksheet 3.7. This is just a worksheet to work on. And so it says describe the error. Talk to your teacher about that one. All right. Number 2, solve for t, subtract 11 from both sides. So I get 4t is greater than or equal to negative 4. Divide each side by 4. So t is greater than or equal to negative 1. So I want values bigger than negative 1 and also equal to. So there's my interval notation. And if we graphed it, we'd get negative 1 here, we get 0, we'd have a solid dot here, and we have it shading to the right. Next problem, I'm going to go ahead and get p by itself, so I'm going to subtract 2 from both sides. So I'm going to get p over 2 is greater than or equal to 7 minus 2, which is 5. Multiply both sides by 2. So those cancel. P is greater than or equal to 10. Okay, so it's going to go from 10 to infinity. On a number line, that's going to go from 10. We have a 0 over here, so I have a solid dot at the 10, and we're going to shade forever right. Number 4, we want to go ahead and get y by itself, so perhaps I add 3y to both sides first. Those cancel out, so that's going to give me 7 plus 12y is less than 19. Subtract 7 from both sides, so 12y is less than 19 minus 7 is 12. Let's divide both sides by 12. So y is less than 1. So our interval notation is going to go from negative infinity to 1, round bracket there. We made a number line. If we had 0 here, 1 here, open dot here, shading to the left to infinity. Okay, on this particular problem, we might add 5n to both sides first. Those cancel. So 5, negative 4n plus 5n is plus 1n, or just n is less than 8. Subtract 5 from both sides. So n is less than 3. So that's going to negative infinity. So I'm going from negative infinity to 3, round bracket on 3 because I don't have an equal sign. If I had 0 here and I had 3 here, I'd have an open dot shading to the left. Oh, you saw it, shading to the left. All right. Then ask your teacher to go through number 13. It's finding the error on the problem. So take care of that. This is the next lesson. This is 3.7. 3.7 is going to be done for another lecture. So if you're watching this in class, make sure you realize that this might be a different day. So 3, 5, 3, 6, 3, 7. Okay, I just want to. All right, worksheet 3.7, you're just working on this. If you just copy these answers down, then that means, again, you don't know that. It means you're copying. So you might want to describe the error. So talk to your teacher about those. And let's head down here. All right, so let's go ahead and maybe add 3n to both sides here. Those cancel out, so I get negative 4 is greater than 7n plus 10. Subtract 10 from both sides. So I get negative 14 is greater than 7n. Divide both sides by 7. So we're going to get negative 2 is greater than n. So flip that over to get the n on the right side. The interval notation that's pointing to negative infinity is going to go from negative infinity to negative 2 soft bracket on a graph. If you have negative 2 here, you have 0 here, you have an open dot, and it's shading to the left. Okay, on this one, if I subtract 5k from both sides, those cancel out. So negative 7 is greater than negative and then 8. Is that true or false? Is negative 7 bigger than negative 8? That's false. It means we have no solution, or you might want to write it as the empty set, that 0 with the big slash through it. That 0 with the slash does not mean 0. It means no solution. Number 8, let's go ahead and combine like terms. So I have 4k minus 6 is less than 4k minus 1. We'll subtract 4k from both sides. These cancel. So negative 6 is less than negative 1. This is true. Negative 6 is less than negative 1. So this means you have infinite solutions, or you might want to write the R like that for all real solutions. Okay, number 9, let's distribute the 9 over the parentheses. That becomes 9p plus 18 is less than, distribute here, 9p minus 15. So this is going to be a special case, like we've just been working. The 9p's cancel. 18 is less than negative 15. This is false. This is no solution. Or you could write the empty set, or no solution, the 0 with the slash through it. Okay, taking a look at number 10, we're going to have to distribute over the parentheses first. And take a look at that and wait till my notebook catches up. Okay, number 10, we'll distribute the 8 over the parentheses. Distribute here, I'm going to get 8x minus 6. We're going to subtract 8x from both sides, and again, we're going to get those are going to fall out. So negative 4 is greater than negative 6. Would you rather owe somebody $24 or $6? So negative 24 is not bigger than negative 6. It's less than. Okay, so this is false. So that means we have no solution, or you could write the 0 with the slash through it. Number 11, we're going to combine these like terms. So that's 5w plus 6 is greater than or equal to 1 plus 5w. So this is the worksheet of special cases, I guess, because those are going to cancel, those are going to cancel. 6 is greater than or equal to 1. This is true. 6 is bigger than 1. So this means we have infinite solutions, or you could write the double R like that for all real if it stays on the page. All right, 3.8. This is again being assigned to you. If you just go copy these answers down, this means you do not know how to do it. You're just copying. So use this as a tool. So I'm going to add 7 to both sides here. So I'm going to get 4x is less than 16. Divide both sides by 4. So x is less than 4. So that's pointing to negative infinity. So negative infinity to 4, round bracket. On a number line, if I have 0 here, I have 4 here. That's an open circle going left. Number 2, let's subtract 10 from both sides. So that's going to give me negative 21 is greater than 7x. Divide both sides by 7. So that's going to give me negative 3 is greater than x. Let's flip the whole thing over because that arrow will point the direction we need to go. So that we want values that are smaller than negative 3. So we're going to go from negative infinity to negative 3, soft bracket. On a number line, we have a negative 3 here. We have a 0 here. Open dot going left. Number 3, how do you feel about clearing the denominator? Let's do it. We've learned it. Let's multiply everything by 6. Those cancel. Subtract 30 from both sides. And then we want to go bigger than that. So 18 soft bracket to infinity. 0 here, 18 here. Open circle, shading right. Let's distribute a negative 3 over the parentheses on this one. I'm going to subtract 39 from both sides. So that's going to give me negative 36 is greater than negative 3x. Divide each side by negative 3. So because we're divided by a negative, our sign is going to flip over. Then I'm going to flip the whole thing back over to do that. So we're going to go from hard bracket 12 to infinity. And you could do the number line. Number 5, we're going to add 23 to both sides. So this is going to give me 48 over here. Divide each side by 6. So I get 8 is less than x. Flip the whole thing over to get the x on the correct side. So we're going to go from 8, soft bracket, to infinity. Number 6, let's clear that fraction again. Let's multiply everything by 2. So I'm going to get x minus 10 is less than or equal to 2. Add 10 to both sides. So that's pointing to negative infinity. So I'm going to go from negative infinity to 12, hard bracket. Again, number line, 0, 12, solid dot at the 12, going to this way. You saw it. It keeps going away. I don't know why. Number 7, let's multiply both sides by 4 first. Those cancel, so I get x plus 5 is less than 8. Subtract 5 from both sides. That's what it looks like. So that's pointing to negative infinity. So negative infinity to 3, soft bracket because I don't have the equal sign. So if I have a 0 here, a 3 here, open dot at the 3 going to the left. Number 8, we're going to subtract 10 from both sides. So that's going to give me 18 is less than or equal to 6x. Divide each side by 6. So I'm going to get 3 is less than or equal to x. Flip the whole thing over to get the x on the correct side. So we're going to go from hard bracket 3 because we had the equals to infinity. You can draw the number line in later. And ask your teacher about the rest of these. They'll go over them in class. Let's take a look at number 13. It says the local carnival students in a culinary arts sells plates of food to raise money for their program. They earn $2 profit for each plate of food they sell and hope to earn at least $75 in profit for the carnival. The initial ingredients that must be deducted from profit was $85. Okay, so they spent $85. Okay, they hope to earn at least 75. So you're going to make $2 profit, and we want to make greater than or equal to 75. I want to make at least 75. So at least 75. I went the wrong way. All right, so I'm going to subtract 85 from both sides. All right, we'll do that in here. Subtract 85 from both sides. You know what? I made a mistake. That should be a subtraction sign. So we need to add 85 to both sides. I apologize. I made an error. So that's going to be 160. So divide by 2, divide by 2. In this sign, we were the right way in the original. I kind of quit doubting myself. I did this too quickly. I'm so sorry, my friends. So if we make 80 or more plates, If we sell 80 or more plates, we are making profit. "14 and 15, ask your teacher. They will go over that in class." All right, and then we have our review, which I will make later. So we did 4 lessons. I hope you have a great day, my friends. Bye-bye.